Finnegan's gonna talk about the, I guess,
Okay,
the
so
thingamaji.
this is my design for LADAR, which uses perspective to gauge ranges and angles up to a theoretically infinite distance. Whoa. The heck?
Don't use the mouse.
For God's sake, don't use it. Just use it.
I'm used to this being the mouse computer.
Sorry.
Okay, so I thought of the, I came up with the idea of doing this when I was reading a Clive Cussler novel and wondering how LiDAR might work. And one of my theories for how it would work before looking it up and seeing how it did was perspective and finding the offset of a laser point from a camera's center. I thought this might be a good navigation tool for a remote control submarine. So I asked Dad about it, and he said that's a good idea, Fenny. Let's figure it out. And so it works on the theory that parallel lines appear to. Wait, what? Okay. Okay. It works on the theory that parallel lines appear to, at a distance, intersect. For example, in this view of the train tracks, we can use an analogy that one side of the tracks is the camera, one is the laser. You can find the distance between the camera at the center and the laser point, and use that to figure out the distance. So if something was near the laser points, 4 of them in this case, would appear farther apart, and farther appear closer together. In these images, the blue would be the actual image. The white is where we're looking for the laser points themselves, because it's a lot faster to look where they're supposed to be than everywhere. And it improves accuracy. And then Grover here is our target. Why is the slide changing up there? Okay.
Do you want me to go? I'll go forward, backward for you on that.
There you go.
Stop.
Okay.
Navigator.
So, stop it.
No, that's far, right? That's where you.
Yes, that is far.
Okay.
Wait, why is that a different slide?
Don't worry about that. Just look at this
Okay. Okay, next slide, Dad.
one. Okay. So that's what Grover looks like far.
Yes, that's what Grover looks like from far away.
And the laser dots are at the.
Yes,
at
the laser
center.
dots are near the center because perspective. Wait, look. It's
Okay.
not. Okay, so we look in each of the
Yes.
slices.
Okay.
Okay.
The top left. Yeah.
Okay, you look at that and talk. I'll flip.
Okay, so once finding it for two-dimensional slices with where the laser point is supposed to be, we compress it into one dimension by adding up the brightnesses, and we can then store it in a list. We look at the Gaussian that the laser point brightnesses changing causes, and try and figure out where the laser point is. It's not 100% accurate, but it's pretty accurate. So to calibrate it, so that wait, what? Okay, no, this is. Why is it not like this slide?
Yeah, we need to look at this.
Okay, this is no. I said there's no mouse.
Sorry, it's one of those cases of everything worked at home.
Everything always works that way before the demonstration.
Yes. Here's a demo. That's weird that it's.
I've never had that problem before.
No, it's- I feel
I've
like
never
it's
done
the
mouse
web
stuff.
browser.
Wait, do other
Oh, there
people,
we go.
do the
Okay.
people in the Zoom meeting see this or this?
That.
Wait, it's the same now. Wait,
Okay, it's the same. So that's.
Oh,
what
you,
we're learning, right?
it's almost like you have to move the mouse to get it to refresh.
Okay.
maybe.
Okay. All right,
Okay.
I'll do that.
So to calibrate it, so that it actually figures out the ranges, not just the laser point offset from the center. We have X figured out by the laser's position, and Y is inputted by the user. So you press the calibration button and type in the distance, and then it would then assume that the surface you're pointing at is perfectly flat or close to such, and calibrate it. You need 3 points at least, although like 5 is like the minimum for any degree of accuracy. So for example, if I were to turn it on and froze it to calibrate at 25, where the laser point was 25 pixels from the center, that might be 10 inches away, and then 10 pixels from the center, you can imagine it being smaller, farther away. It could be 20 inches away, and then last 5 pixels from the center be 25 inches, and it would then interpolate and extrapolate to figure out ranges at pretty much any distance. So it used to be trying to fit a hyperbola, but that was not too accurate, even though it should be a hyperbola in theory. So instead, we tried doing a first order spline, and that worked pretty well. But we're hoping to get a hyperbola working eventually, because then you need a lot less coordinate points to actually get it to be accurate. The first order spline, it's extrapolating is difficult, so you need a lot more points. For subtraction of the background, since you can't really have like a bright light or the sun like messing up the range generated, we take multiple images with the laser off, or in this case covered up by someone's hand. And then we take the average of those images, and we can turn the lasers back on and subtract that average from the frame we get to make the laser points stand out a lot more. This dad. Okay, this was really cheap to make, a total of around $35. The lasers being the most expensive part of $12, and the nylon screws then at $10 pipe, PVC pipe for the actual setup, $3, and the feet to adjust to make it point parallel to the ground, $10, and the feet were not even strictly necessary, so you can imagine it was incredibly cheap.
Nice.
And now my dad is going to show you the boring parts, and then we will have a demonstration where hopefully everything will.
All right. Fingers crossed. Okay, so I was given a talk in the optics department years ago, and I asked a grad student who was looking at it, should I cut anything out? And he said exactly that. Don't cut anything out, just skip over the boring parts. So that's like my motto. The code has some structure. I think, let me skip that and come back to it if anybody really cares, because I think the actual code is more interesting.
If it's interesting at all.
Okay, so to acquire images from the camera, we use OpenCV. And the main loop, the meat of the main loop is just this ImShow. You give a NumPy image frame, just a NumPy 2D array to ImShow, and it'll display it. It'll pop open a window. You don't have to create a GUI or anything to just get started. It's got a zoom. I can show you. It's kind of cool, but so that's the meat of the thing. And then I'm kind of working backward here. Like I'll show you what we did, and then I'll show you the next slide how it works inside. So we've got a class that will capture the frames and prepare them for the rest of the code. And we create a video capture class from OpenCV, and that's just the name of the camera /dev/video0 or whatever it is. And then
the name in the system, or just a random name you give
yeah, so in Linux it's everything's a file, so it's /dev.
But okay, so but it's a system.
The system's name.
Yeah.
Yep.
Okay.
Yep. And so I'm calling that a capture. So that's self.cap. And then we make a queue. I'll show you why we need a queue. And we start a thread running a function. This is just the Python threading module. We start a thread running a function called reader. And so we tell it we want that in daemon mode. I can't even remember what the difference is there. And then we tell it to start, thread start. And the reason we need a queue is the camera will buffer images. So if you're not pulling them off as fast as it's taking the images, they'll pile up, and then eventually you'll be in you'll be in a lag. You'll see things from a couple seconds ago. And so if you want it in real time, the Stack Overflow told me to do this. We just make a queue, and the camera is putting images on the back, and then we're just pulling them off the front and throwing them in the trash unless another part of the code grabs one to use it. So I don't know if there's a better built-in way, but this worked. So so the reader, this is the reader thread, and it does just what I said. It's got a loop as long as it's told to be running. It'll get a frame, and I don't know what's in the return code, but it'll get a frame from the OpenCV image capture, video capture. If the queue is not empty, it pulls off a queue, or it tries to pull off the frame off the queue without blocking. And then if it gets a queue empty error, that happens regularly, so you just skip it and go again. And then as we're pulling them off, if the queue is not empty, we're also putting on after that, putting on the next frame. So I'm sure you can kind of miss frames that way. You try to grab a frame and it's not ready yet, but it doesn't matter a whole lot for this. And then we'll use image queue, the .get method, to get the most recent frame off the queue. So that's in this get frame function, and we do that .get on the Python queue object. So we get a frame off, and this frame is actually it's actually three-dimensional, so it gives you three 2D arrays. You've got the red, the green, and the blue separate. And we're using the red now, which I think makes sense because we've got a red laser. So we take this is the notation for take the frame and take all of X, all of Y, and then for Z take just the 0, 1, or 2 channel. So it would be like red would be 0, green would be 1, and blue would be 2. And then if we have a background measurement, we'll take the frame and just subtract the background from it, and then we return the image frame. And so now this thing's kind of lagging, but hopefully it keeps going. Okay, so how do we subtract the background? If there's no background, we can't subtract. Oh man, my GPU is like throttling back. It's chunky thing. All right, fingers crossed. Okay, so if we have a background, we take the image frame that we got and subtract the background from it. And the .clip we're using to make sure we don't over subtract, because the image frame is in, what's up?
Can I close the other tabs?
No, don't do anything. For God's sake, don't do anything. Thank you. Okay, so we don't want to over subtract because the image frame is 8-bit unsigned integers. So if you over subtract, you get negative numbers which show up as bright spots on the image. So be careful not to over subtract. And this, I think, is slightly more interesting than just the subtraction. This is how we get the background. You ask the acquire background method here to take n frames. I'm going to stop moving the mouse because it's not even keeping up. And then we just create that sum frames variable. We step through counting up to n and get a frame from the methods I showed you before, convert them to float 32. And this is all NumPy operations. All the images are NumPy arrays. And then we put the first incoming frame into the summed frames array. And then all the subsequent ones we add down in the else. All right, move slowly. And then we take the summed frames and divide it by the number of frames. Right, so now we have an average frame, so its intensity should be scaled the same as all the future incoming actual frames. And we convert that to a uint8 for 8-bit images. And then we set the background equal to those. And then we set the background equal to that average. So now we have a background we can subtract. So I'm going to skip this. I don't know why that's in there.
That's because it's all the stuff the laser does.
Okay, the laser does a lot of stuff. The laser class, maybe it's worth mentioning. So the laser class, we don't control the laser. It's just operating on part of the image frame. So we give each of the 4 laser objects a whole image frame, and it knows what slice to take out based on whether you told it it's the left laser or the right laser or whatever. So it's doing all the spot finding things. And then, so Finnegan mentioned that we slice the frames. And so this is a 2D slice, so this could be like on the left side, if it's the left laser, we'll take this chunk. This is the array notation again, it's not real important to, if you haven't done this before, to understand it exactly, but basically we're taking the full image frame and we're taking from lower slice limit to upper slice limit, and I marked those on the picture here.
At
Yeah.
this point, do you know what those limits are?
They're just fixed. We
Okay.
decided what slice we're gonna look for the laser in.
Okay.
And we line up the laser, so it's always gonna be in that slice when we're moving the.
But
the
it'll-
frame around.
Oh, because the laser doesn't get bigger or smaller. Oh, right.
I mean, it does slightly.
It does
Yeah.
a little, but,
Yeah,
and you can make it, I don't know.
Yeah, it's.
Everything we did here needs adjustment. It's kind of like, it's kind of working, don't mess with it.
It's
Yeah.
50 pixels wide, so there's some margin there.
yeah.
Is it 50? Oh, okay.
Yeah.
So, yeah, so we cut it, top to bottom like that, and then we cut from the left side to the center of the frame. Right. Then we do a fit, and so initially we were trying to do a 2D fit. You can fit a 2D Gaussian to a spot in the picture. It's really slow, it gets, it throws exceptions, and then it takes time to recover. Eventually it'll find it, but it's just, it drags the whole thing down to a halt. So, so we sum this thing top to bottom, and we sum region slice. Zero, the zero axis would be the vertical axis here, and that sums it all down to a 1D array. So, not doing 2D fits, we get the 1D array, and then we do a fit, and I don't think it's worth going through all these numbers here because you know the rest of the code. So I'll just point to the meat of this stuff. We set bounds for the fit, and these are bounds in all the three parameters that's fitting are the brightness, the position of the laser spot, and how wide the spot is. So we call, this is our fit function, fit 1D Gaussian. We give it that one-dimensional slice right here. And then we give it an initial guess on where the spot will be. And which doesn't matter a whole lot if you subtract the background well, so we'll show you that when it's in operation. And then after we do that fit, we get these three parameters out. We get that fit center is what we want. That's the pixel position, the number of pixels from the center of the frame where the center of the laser spot is. And it's going to jitter around, right? You're making a measurement, and it's going to jiggle. We'll get the same number constantly over time. So to get rid of that jitter, that's I didn't show this yet. So to get rid of the jitter, we do an averaging. So we've got another list of recent n centroids, and so we keep maybe 10 centroid being the pixel position of the laser spot, right? So we keep like the last 10 positions. And every time we go through this loop and find the next measurement, we pop off the oldest one off the list. And then we put on the, newest position measurement onto the back end of the list. So then we can just take an average. And so every time we're getting a readout on our terminal here, it's a time average of like a third of a second or something like that. And if you don't do that, it jumps pretty wildly all over the place. So I don't know, people are probably, if you want me to go back and talk about the math, I can definitely do that, but I think probably people are more interested in what they can do playing with Python. This is our fit 1D Gaussian function. And that basically calls the heart of that is this SciPy module as an optimized set of optimized tools, and the one we're using here is curve fit. So it fits this bumpy, or it fits a Gaussian shape to the bumpy laser spot, and we tell it what function to fit. It can do in principle just about anything. We give it the X data, that's the pixels from the left side, negative 160, up to the right side of the slice, positive 160. And then we give it the brightness data, that's this Y data. So we just give it the pixel axis and the brightness for each pixel. And we tell it to do the fit. And one of the things that's really neat about this is you can tell curve fit to fit this function. And you don't tell it here what the parameters are. The parameters are where the spot is, how bright it is, and how wide it is. But it does, I don't know if you call this introspection or what, but the cool thing is this is the function I gave it that I defined up here. It could be anything. The mouse ever gets there. So, and it gets the X values. It gets an array of X values, and then it calculates a Gaussian. It has those three parameters: height, center, and width, brightness, center, and width. And so that Gaussian, that SciPy curve fit, does some inspection in this function that you gave it, and it figures out that everything after the X, those are the parameters it should adjust. It adjusts those to give you a best fit, and then it gives you the best values. So it's, that takes all the work out of, you just tell it, please fit, and it's very robust. It's hard to get it to not, can't get it to crash. In worst case, it gives you an exception and it's right back running, right? So, so this is fake. I didn't have a chance to make some nice graphs, but this is what the 1D laser spot would look like, right? So the brightness is the higher it is, the brighter it is, right? But it's all jittering up and down. And so that stuff I showed you on the last slide fits this red Gaussian shape to it.
But it's not really the brightness, right? Like you could think the laser dot could be a uniform brightness, but when you collapse it into 1D, the edges don't contribute. It's like you're summing the,
Because the laser point is spherical.
Yeah.
If it's perfectly uniform brightness, once you collapse it, it would still make a Gaussian shape.
yeah, yeah.
The fact that it's not perfectly uniform brightness only amplifies the Gaussian.
Okay.
It doesn't have to.
So yeah, so that's the fit it's doing to find the spot. Now it knows how many pixels the laser is from the edge. And then we just have to calibrate and get for each pixel position, we have to be able to translate that into the real world distance. How far away is the object we're looking for? And again, if anybody wants to talk, I mean, everybody hates trigonometry from high school, right? So I won't go through this unless somebody really is curious, but if you do the trigonometry, it's not too hard to figure out that you should get a hyperbola. The real world distance y should be some number divided by x, the pixel distance of the laser spot from the center. And if you try to calibrate that, just another fit, I'm not going to show the code, but you do another SciPy optimize curve fit, and it finds a best fit. And these are the calibration points we used. Those don't mess with anything; it's going to explode. So those are the calibration points, the circles, and then it did a best fit of a hyperbola, and it didn't quite work. And there are geometric reasons for that. I think the lasers probably aren't pointed quite straight, and other physical issues. I don't know. So for the moment we're skipping that, and then we're using a spline fit, and this is another cool tool from SciPy. You just give it data and X data and Y data and say, give me an interpolated spline, give me a smooth interpolation between the data points, and you tell it what order, so you can have linear interpolation, little lines connecting the dots, or you can have parabola slices connecting the dots, or whatever. So that gives you a spline object. And it returns that, and then you just throw numbers into the spline object, and it gives you back for an X that you give it, it gives you the Y value. So the line here is what comes out of that spline. So we took 4 calibration points, told it to fit a spline, and it did. So and Finnegan mentioned before, I think that we wanted to get it to work with a hyperbola, because then that's the sort of physically, fewer calibration points. So we want to get the real function that it needs, and then we don't have to calibrate 20 points over the range that we expect.
It does work really well.
It does work, yeah.
Really fun.
So to get the hyperbola to work, it's more of a mechanical issue. Like you
Yes,
have
I
to
think it is, yeah.
get lasers really straight. I don't know. That sounds like I wouldn't want to work on that.
Yeah,
The cam is on like a pivot thingy, so like
Oh,
if you
yeah.
breathe near it, it will bend a little.
yeah. I don't know if there's distortion in the image too, or whatever, but
Right,
So,
like
I don't know.
aberration.
we'll see how hard it gets. Or maybe we'll just guess the right function and sometimes add an X squared to it and it'll work. I don't know. So anyway, so that's pretty good. That's our calibration, the quadratic splines. And then we use the spline function from SciPy. We give it the, one second. Oh, yeah. So that's the, we give it the spline object that it created in the fit. Use the spline check function, sorry, and give it here the spline object that it created, and then give it a pixel distance from the center of the frame to the laser spot, and then it gives us the Y position. And then more math. You get,
It's just for finding the angles if you have two or more lasers.
yeah, so we can turn the object now, and the distance on the left changes, different from on the right, and then you can get the angle that you said. And we'll do a demo. I don't know I hope we're not running out of time, but we'll do a demo if nothing breaks. But before that, I just want to say cams are great. Finnegan has all these brilliant ideas and I want to try them, but every time it comes to we have to get out a soldering iron, I'm like, I don't know. So getting stuff to interface to the computer, especially if you just got an ordinary laptop, is not always the easiest thing. It's usually kind of complicated, right? But with a camera, anything you can get to show up as a change in the image, you can measure. So you can do, you could look for a bright flash of lightning.
Congratulations.
And then use the microphone.
You just became an astronomer.
Oh, you can do astronomy, that's right. Put a little telescope on it. Yeah, so you can time the distance between the light flash and the microphone. Bang, boom, the thunder.
I used to triangle, though.
And maybe you could triangulate, yeah. Maybe you could just like that with more than one camera, more than one station, right? You could do just random ideas. You could look at a shadow and figure out the time. If you're worried about water leaks in the basement, I don't know anything. I can just plug into the computer and do that. But I mean, I could put a webcam somewhere, and I could maybe shine a light at the floor. And if the color of the floor changes, then I know I've got a water leak or something. Speakers. Or put some construction paper, and if it darkens, yeah. And then this was kind of cool. It didn't work out in the end, but we had during COVID remote work, there was a guy in Chicago who had a hard drive on Long Island, and I was in Rochester, and we were trying to figure out what to do because it kept timing out and shutting down this external drive. And we didn't know what to do about it. And I suggested, we've got a computer there. Why don't we get it to emit a couple of loud bangs and get a clapper, the lights on, and put a clapper, instead of a lamp, plug the hard drive into it, right? And then power it off and back on, and there you go. And the people at Brookhaven Lab said that's not professional. It didn't happen, but I think it would have worked. So cams are great. You can, you put a cam or a microphone or whatever with SciPy, and you can do almost any astronomy. So I don't.
Yeah.
I wonder how many people are watching it.
Just one.
Just one. I don't want to leave anyone out, but I'm having trouble now sharing the full screen. So
Or do it on the other computer.
I'm gonna do it on that. I can do it.
It's
without
all right.
installing
It's
it.
all right, Adam.
All right. Let me try to put this one on, and then.
Now can I close some tabs on this?
No, don't do anything. Don't do anything. Okay.
I'm
You're gonna have to stop sharing, I think.
Oh, I can stop on that.
okay. I want to close some tabs. I'm closing tabs.
It's
I'm closing tabs.
All right,
like,
whatever.
it's
Close
kind of
it-
like
close
deleting
it all.
code. It feels so good.
Can I just close them all?
You can close them all. Did that stop sharing? I hope that didn't
No, see, it's-
locked up.
There it goes.
What do I go to zoom.us to this one
Yes.
is really new, so.
Well, you probably go to Meetup to get the link.
I think I found your password thing or something.
Yeah,
so
get
if
out
I
of there.
press
Just.
that-
Okay, so I think I
Can I close this terminal?
just don't worry about that. Let's focus. on
Oh,
this.
yeah, it's in the data.
What's the meeting ID again?
832-077. Oh, that's the passcode. The meeting ID.
Oh.
Is 849-3090-7382. That's good.
Oh, passcode, yeah.
832-077.
Okay, all right, fingers crossed on this one now. And I'm joined, I guess I'm at the waiting. Do you have to click me? in?
Yep, I see it, I see it.
Ah. You got Zoom on here, okay, hold on one second.
Got it, got it.
There, got it, yeah. Hold on,
Join my computer.
I want to break this, not you. Hold on. Join
I
this
like
computer.
this.
Don't do audio, because. Yeah, do audio, okay, do audio, all right, that'll work, just can't.
Look, it's your name.
There we go. All right, hold on, Penny. Hold on. Okay, so we're gonna start up our,
Okay, so,
but you're not sharing yet, so let me share the whole screen.
no, I share.
Okay, go back
How
there.
do you share?
Let me just do this and then I'll. Oh, come on, Zoom. Oh, there it is.
Okay, no, I share.
Share, yeah. Do share whole desktop.
Use
Yes,
this-
that one, yep. Yep. No, no. Okay, see any, all right, okay, now you can go to the terminal. Three fingers.
Ah.
There you go. Yep, okay.
So, so this is a LADAR virtual environment. The command to start it is LADAR. And theoretically, it should work.
You've got to give it the device, so up arrow twice. There we go, yep.
Okay, so this is in only red, it shows the brightness and stuff. And what we're gonna do now is I'm just gonna do a quick demonstration of background subtraction
Oh, yeah, yeah.
and its awesomeness. Yeah, shut up with this, I know it's not fitting. So this is it without the background subtraction, and I'm just gonna zoom in on one random point. Scrolling, 2-finger forward. Yeah, okay, so this will actually show you the
Oh, wow.
values of the pixels.
Well, that's pretty cool.
That's
Um,
that
and-
is super cool.
Yeah, as you can see, it's pretty bright, and I press B for background and bam. So you can scroll back out, it's nothing, it's not like the crosshairs, it's just black. And then the best part about this, 1 second, Dad, press B, right?
Cool.
Nice,
Yeah, I can invert it.
There we go.
awesome.
We're looking at image subtraction.
Oh, that's cool.
Yeah.
Yes.
Very cool.
It looks like an X-ray kind of. Anyway, right, lasers.
Well,
So,
do you want a background again?
Oh, we're gonna have to do it multiple times, we don't have it
Yeah.
Oh, okay.
tuned to the automatic, you know,
um,
keep subtracting. I can do the tweaking if you want, you can do the.
I like to.
Oh,
Cover up the lasers, Dad. Go on the other side, cover it up. Oh, wait.
There we go.
oh, you know what to do.
Okay, uncover it. Okay, uncover it, and you have 2 points, let's see if it's fitting. I think it's fitting.
Turn it off and on.
It seems to be a reflection of,
Yeah, you're right. You can see it.
And by the way, there are 4 spots, it's looking for 2 other lasers that we don't have, so the left and right are.
yeah, these 2 lasers should be turned on, but we don't want to because they're glitchy. Okay, so now I'm gonna take a calibration point. If Dad will move the box forward to the nearest distance of what which is. Is it what you're doing? Right,
And now you can see it tracking. And,
Oh,
and if you do, can I just do the little track, put it on your hand.
yeah, just go on the other side.
All right,
Go on the other side.
On the blade.
Other side, other side. Yeah, as you can see, the background subtraction is very sensitive, and we now see a picture of the box when it was far away. Covering up the lasers, push E, and bam, it's now locked into the laser points. That didn't work too well because the lasers are very bright up this close, but we can take a calibration point by pressing C. It asks
Now you gotta click in the terminal.
for the
and
distance
This 12.
in the main terminal. Yeah, I'm not full screen that. How do I move?
No, don't full screen.
I want to move this thing out of the way.
There you go.
Yeah, I agree with that.
Ah, okay.
All right, so distance is 12. And no. Most
Okay,
of the
now you gotta
distance is
click
12.
back to the window.
Yes, I know.
Okay, all right.
And then Maggie will very kindly, that will kindly do.
24 or?
Yes, let's say 24. Let's do the nearest one. That. So we're gonna do background subtraction. It's very, like, it's obviously very effective subtraction. I did not realize how close it was. All right, something background, but that's fine. Calculate. Distance is 24. You can do this in whatever units you want. It doesn't return it with the units. Dad, it's returning 0 again.
No, that's okay. You gotta get 3 points.
All right. All right, now we have
36.
yes. Thank you. All right. So as you can see, there's an obvious distance in the obvious difference in the distance between the laser points and the distance from the laser point to the camera. That's the theory that LADAR works on. That's 36.
36.
All right. All right, so now we're returning a distance of 36, an angle of about
You wanna say
0. And then
numbers are, it's hard to read. I'm
yeah,
sorry.
so this, yeah, this is the distance for the left laser, right laser, which are both exactly 36. Why did it just print it again then? Oh, well. And then,
I don't know what's going on, but just look at the bottom line.
and
That's
then,
my fault.
these two thingies are the top and bottom lasers, which we did not have turned on, so it's like going all over the place for them. Stop it. And then, this thing is the angle, which is getting wrong because it's a new thing, but still. And we're gonna demonstrate by moving it to, something that we did not actually give a point for. That, we'll figure it out. Move it to 14 inches.
2 inches.
Yes. And even if it doesn't actually give you the actual range, it is incredibly sensitive.
You wanna do it without background subtraction and just see if it tracks?
It probably will, but I like background subtraction. All right, we'll try it.
It actually, it subtracts. Can you turn it off?
All right.
I mean, look at that. It's tracking. Yep,
Lost
we lost
one.
one to the bright. where the bright
Oh.
window is there.
Nice.
All right.
There you go.
And generated range is 11.
Nice.
11. That's
It's not perfect, but
What'd you say it was?
It-
Measured?
it's
14?
14. All right. All right.
Oh, yeah.
Wrong thing. 30.
But that was only 3 calibration points.
Yes, it
Yeah.
needs like a minimum of 5. 14. Move it to a random distance, Dad, okay.
so about halfway here. We'll do it at 6:30. Okay.
30. All right. It's tracking them both, so we don't need
At
background.
about 30. Does it read 30? Oh, you can calibrate.
Wait, let's see if it does. Yeah, it reads 30.0 and 30.0. All right, try this. It's still at 30 to 30, but we are tipping it. I'd say that's around 45-ish, right?
Maybe.
I don't know, and it's returning 50 degrees. I think that's actually not fair. This should be,
I mean, it's hard to eyeball.
Yeah.
It's like that.
some piece of paper and pull the right angles. I don't know.
Where's your protractor? I forgot our protractor.
40, if I can. Yeah, this isn't working too well, but it still gives you the angle. It's the theory that counts.
It seems like it's giving you new lines when T is negative.
Oh, the terminal's small. I bet I like padded, it's just really hacky. I bet I padded with some space.
So I have an idea.
Let me, let's see if this gets the 45.
Daddy, your forehead is changing brightnesses very quickly. Wait, is this Dad's forehead still? Oh, no, it's not Dad's forehead. Okay,
Or how about that? Does that show?
wait,
up?
I want to see how well this works.
It doesn't have the,
Take that, then about 45.
1 second. I want to see how well the laser point can subtract.
oh, it's just saturated.
Holy cow. Oh, that's the crosshairs. Yeah, that's the crosshairs. We actually manipulated the pixels in the, whatchamacallit, to not like, it's a very hacky thing. it makes us lose a lot of data. What's this? Dad, are you bleeding in the mouth or something? Oh, that's
Oh,
the
that's
background. Okay.
So what's the angle? That's about 45 here.
Yeah. We got it.
It's coming out.
Okay, Dad, laser. Oh, thank you. All right.
But do it one more time, because like, that was my fault.
Yeah, if you move it, this thing's very sensitive.
There you go.
All right, that's, yeah, the angle is 38, 39-ish.
That's probably about right.
I mean, it's
You know.
supposed to be 45, but still, it's needs a little work in progress. Can you turn it back to 0, Doug? I wanna do another calibration point. What range is this?
That's, oh, you want to do another, we did 36. So
Yeah, just do one of those where it's really far away and see if we can circulate.
you want to try 72?
Sure. It's not tracking.
You want me to stay here?
You're fine.
Oh, yeah, it doesn't look that much. All right, thank you.
Trust and putting in suspension.
What did you say it was, 72?
Yeah.
Yeah, it's bad at extrapolating, it's really bad at extrapolating at this point, so.
Do you know why that is?
Because it has to guess, right? It's trying to fit it as smoothly as possible, whatever way necessary.
Yeah.
Calgary, 72. Why did it say 11? Debbie, it says 11.
I think you lost the.
Yeah,
Don't
yeah, I
type
think
in- Don't
it's-
type in 7.
Because,
What
Just
should I
hit
do?
enter.
because you can see in the background, your crosshairs way off
Oh,
the right.
That may be me, sorry. Then stretch
Very
the
left.
terminal wider by the bottom right corner, and then you stop that scrolling. There we go. The
Interesting.
bottom one's good.
Yeah, what?
Control
It's got
L.
pretty pattern.
Press Control L.
Oh,
Okay.
That, oh. Yeah.
That was priceless.
But that's kind of scary, right? That crosshair tracking Richard.
Thinks you are a laser.
I may have missed it.
He is pretty bright.
We just don't have one.
Why is it? Okay, 60 inches. Thank you. All right, it returns 62.5. I mean, it's not bad. But I would like to demonstrate my favorite part of this. So it's at, we'll say 62-ish. If it continues tracking correctly, and I'm gonna move it around 1 inch, exactly 1 inch. Just to demonstrate its sensitivity, and it is now at 62.60.
It's, well, then it's their little tracking, which is there up in my fault, and I think that's why.
Your fault.
But you can
Okay.
see, you can see 1 inch resolution.
Yeah, that just move it
Pretty
slowly.
easily.
Go over, move it
A
slowly.
little bit.
Okay, so we have 62 and 61. Should we do background?
So if the box is.
You know what? We only need one laser, right? So. As long as we're okay with not having.
You measure from the extent of the box surface, where do you measure to? Of the apparatus.
Oh, the camera's in the middle there.
Camera, the aperture of the camera is where you measure to.
Yeah, oh, yeah.
Yes, because laser could be theoretically anywhere. We could have it way over there and it would still measure. It's perfectly parallel. It's not, so it does matter in position still. What's the actual distance then?
60.
Yeah, this is
If you
not
watch the
this.
screen though, you can tell when it.
Stay still for a
tracks.
second.
But it's 1 inch farther.
It's 60 right now, and then.
Yeah, why isn't this working? Oh, wait, we're looking at the right laser. We're looking at the right laser. Looking at the
It
wrong
just
one.
needs a little.
62.5.
to it.
I will say this, it worked at home. It was incredibly accurate. Like to the point where I didn't even need to take measurements. Just knew it was
With
right.
the two lasers.
Yeah, it only takes one in principle to, and then you can average, right, because it's just.
Background
position
spamming.
spots.
Lag.
I'm gonna say parallax, I thought you were talking about.
Yeah, not in that sense. I don't know if it's really.
Wait, I wanna track my father.
Well,
I don't even remember what we.
Daddy, it's not tracking.
Parallax would be you moving the camera, right? And the object is this thing, so at least in the astronauts, right?
Right.
Hello, father. I love this thing. Wait. Isn't this so cool though?
Yeah,
Look, and then background, bam.
That's a pretty good subtraction.
Maximum
really
you see
good.
is like
I mean-
20, and that's because people are talking.
Yep.
Yeah, maybe I should not do this on a living person.
Trying to show you that.
I don't know what time it is.
oh, and it's 9 o'clock.
Oh,
Yeah, thanks.
so,
Um,
oh, you turned it.
yeah, I see like a maximum of 10 in some places. This is
So,
cool.
Ben, if you point it at that wall, the calibration will still work, right? Calibrate it. If you point it at that wall where there's no light pollution from the windows, I'll bet you can show.
sorry
a
about
window, and then just turn off the, background subtraction. I'll bet you can just turn it right off, and then you can move it forward and backward, and I'll bet you'll see 1 inch, change.
Just
Just look at one,
laser.
that's okay, just look at.
Okay, which laser is that? Because
The
it's
left.
sometimes
It's reversing this.
Oh, it's
okay,
reversed.
right?
This is a really tough image to.
Right.
Why is it so laggy?
Yeah, well, I think Zoom or something overheated that.
Okay, well, anyway, 1 inch-ish.
Oh, we get Zoom running at the same time too. So 60.
Yeah, we'll just say 60.5.
Right there, you can see it, right?
That sounds a bit round an inch. And it's now 60.6, 7, what the heck? Is it tracking? It's tracking.
So, I don't know,
Where did that?
people want to fiddle around with it or talk about trigonometry or?
This is really cool.
I think the crosshairs are the best part. Yeah.
Oh, it's right in my forehead.
It's tracking my father. Wait.
Target identify.
Seriously.
Man. It's just kind of,
It's done. Look at that. They can't use my phone.
Daddy's head is too shiny. I like this, it's fun. See you, Rich.
Well, I feel like we shouldn't sit here and.
Yeah.
Play with it on our own for an hour, but I don't know. People want to fiddle with it or?
Come here if you'd like to play.
Did you consider, instead of a continuous camera feed, like just taking images?
I tried to get Dad to do that.
I mean, it essentially is, right? We're doing the math on every
Yeah.
sequence of images and averaging, right?
Yeah.
So. Or you mean just like, oh,
Yeah, no, I know, but instead of, I don't
take a
know,
measurement, stop and
yeah,
that's your reading. Yeah. I don't know, what are we gonna do? It's gonna be like that.
I think we want it so it spins, so you have a cool radar picture,
yeah,
radar looking picture.
but you have to hook up clappers to the laser so that you can turn them off. Shake
Oh,
the back
yes.
and
We're gonna
turn them on again.
Yeah,
We're
we're
gonna-
trying to figure that out. There we go.
We're gonna also have shutters so that we shut the
Shutters.
laser blinking so that it fits a lot more easily, because not many things naturally blink.
Okay.
Which should improve fitting accuracy a lot, which should also in turn improve calibration and stuff.
Yeah.
I think part of the reason when it's not as accurate this time is because of the lights and because it wasn't as accurate in the calibration. And it was gliding off to little points. Like, for example, if I move it a lot, it like doesn't go instantly.
And that's that averaging for government.
Yeah, you can see it like runs out to a new
Concentrate.
place instead of appearing in that new place. So I think maybe I didn't notice it and calibrated it instantly. Right? And calibrated it without
And
checking
can
it.
it-
Yeah, yeah.
Position.
Look at this, though. This is the,
What are you doing? Oh, and another thing, the camera is autofocus, which really messes up accuracy.
oh, that's what happened then. It was refocusing. So that messes up our measurement.
Oh, according to the top laser, this thing's around 4,640 inches away.
It's not on. So. You can shut off like. Yeah, I don't know.
We were trying to figure that out, didn't work too well. Yeah, but the final product I want it so it spins around, it spins like 1, 2 degrees, maybe up to 5 degrees, takes it back into subtraction, turns the lasers on, takes a picture, a couple of pictures so that it can see blinking, or maybe even a color change or motion of the lasers, and then just continues, hopefully up to like maybe 1 revolution every 10 seconds.
There you go. And then you can sell it to Tesla.
My original idea for this was, of course, to use through water, since I don't think you can, I mean, radar technically works in water, but not well. I mean, it works, but not to any useful range. And since lasers can come in colors that will go through decent amounts of water, including blue and ultraviolet, I thought LADAR might actually work for this. I wanted to track my father, Dad, get back in the image.
Well, should we end it about there, Finn, and
All right,
people can leave or ask questions or play with it or whatever. You should let them play with it. They can move it
oh
around.
yes, come here. This is a list of what the keys do. That is the target.
I want to ask about curve fit. So did you use that when you're at your last job?
No, I didn't. No, we just Googled it. And,
Oh, really?
yeah. I mean, I used sci-fi before, but
Yeah.
I guess I had in the past, like way back in the past. But yeah,
Okay.
it was fresh for me this time. But it's really robust too. You know, I mean, it'll admit an exception, but
Yeah.
It doesn't get caught in a loop. It's
That it's really lagging behind.
Yeah.
Like, but
Yeah, Zoom does that to all of us.
Yeah.
put my hands on.
Wow.
Yeah.
Okay, off 1, 2, 3.
wow.
Yeah, that's not good.
Okay, so that's Zoom because the cue
Yeah.
that we were talking about before is pulling off frames as fast as it can, but for whatever reason, it
Yeah,
can't.
for sure. No, Zoom brings the best computer to
This
it.
isn't the best computer.
Yes.
And it's not the best. That's right.
Can I
That's right.
please have another bit of, did you finish your donut?
All right, focus.
Yeah.
Wait, Daddy, can we
Your
do
mom's
the,
watching.
wait, I wanna do the graphic thing. Do the graphy thing where it shows the spline thing. Come
Oh,
here.
I don't know that set up, sweetie. I don't know.
Oh,
that
come
set
on,
up. But we
please.
showed it in the slideshow.
Set it
I
up.
don't know if it's set up. It's just not. I can't do coding live. It won't work. It's not a job interview. Well, anyway, Finn can play with this all day, but
Yeah.
Yeah, if you want any questions or see something happen.
I want, so, because these other lasers are so bright, I wonder if that also distorts, like, contributes to the error, because, presumably,
yeah, because it fits onto the edge of it sometimes there, right?
It's
Yeah.
Kind of makes me think it's like a speck along the side
Yeah.
or something.
and like you're saturating the pixels, so like,
So
yeah.
maybe it's like
so the, yeah,
flat.
Sorry,
Yeah,
I like
yeah.
your background.
So eventually I've got to just like keep a running graph so we can actually see what's happening.
Yes.
I think, So I don't know, my next idea is a graphical interface so we can twiddle knobs live instead of
Yeah.
stopping, changing the code.
Daddy,
And see what's happening.
what will happen if I press enter?
I don't know.
Yeah.
Oh, okay.
There you go.
It must have got it in like binary or something.
Does anybody have a recommendation for like a real
Something you could do.
turnkey-ish
A job for this
graphical
thing.
interface? But
No.
like I've used PyQ, which has a lot of kind of
Not
overhead.
really.
Wait,
We
Look,
used
someone's hand
PyGTK a
is-
while ago, but
so, but, like, you can use Plotly,
for the output. For the graphs.
it takes input, like, I don't know if it actually goes, yeah. Because Plotly has a whole bunch of interactive plotting things, right, so theoretically, I don't know if it just
You
has
could
like
have to be a slider.
you could definitely have a slider,
Oh, okay, there you go. And that's in the browser, right? Plotly.
yeah, yeah.
Okay. Okay, that might be a nice way to go to start, because I don't have, I don't have all day to. Do all the boilerplate
You don't want to use Unity?
stuff. I mean, look at this computer. I mean,
It's-
I don't think that would handle Unity. Catch fire.
that'd be cool though. it knows there's supposed to be light here, so it's tracking me.
Nice.
Oh, and there's this weird thing where like it's some sort of like glitch or something where when it gets to this like near edge position, it doesn't show the.
That's my good.
Yeah, it was all Dad's fault.
So this is just the red channel, this is the laser, right?
Yeah, Dad, change channels.
So how much red light is that exit sign putting out?
Is what?
The exit sign,
Oh,
it's all green, right? So is there some red component to its light?
It's partly glitched by the
Or is it that-
brightness, so.
But we need to zoom in.
I think it's behind the,
Oh, that's pretty dark. Wait.
No,
That's
there's
super
no-
dark.
that's not right. Yeah, this is the stop sign. It's
Oh,
green.
yeah, that's it.
It's really dark. Yeah, that's interesting. I never thought about doing that.
I mean, it should be dark, that's what I would
Yeah.
expect, right? So-
Yeah, you can see a little bit of white.
And then
At the
there's
top.
some sort of red dot.
So
Yeah.
for now it comes back, that's what I'm.
Oh,
Yeah, it's probably just a reflection of everything. Red is very like it's everywhere in the ambient background. So we were thinking of trying blue because lasers did show up in blue and
so there is a red light up
like
there.
no,
everything.
yeah, I know.
So we were thinking of
Yeah.
doing blue and it didn't. It found it actually better. Even though the lasers are monochromatic and red, it found it better when we used blue because there's so little background. But background contraction, I think, has canceled out that advantage. Oh, that's my mom. This is my mom. Hi, Mom.
Hi, Mom.
Hi, Rachel.
Rachel, do you have a question?
Hi, Mom.
Do you have any questions?
She can't talk.
She's watching with an astrophysicist at home.
Oh, yes.
And
Wait, Preeti's
Rich
on here
knows-
too.
Oh, there we go.
Wait,
She's what?
what's going on?
There's somebody,
Hi,
a friend
Preeti.
visiting
If
from
you're here, Preeti,
India,
hi.
and she's in astrophysics.
How do I move that? Hi.
I have no idea.
Hi.
You have to
Hi,
ask her.
Daddy.
She's there.
Preeti.
Hi, Dad. Hi, Finnegan.
Wait, how do we get this to
We're
work?
not getting an image yet. I don't know.
No.
I wanna.
But Rich, if
Let's
you
start
could-
video. No, click on
Rich is brain about
Yeah, I did that
imaging
already.
and
I
stuff
thought
too,
this was the
right?
Click
one.
on mute.
You did astro.
Click start video.
No, it's
No,
not.
I don't, no.
Oh, no.
Okay.
Hmm.
I mean, I worked for astronomers.
No, I was Astro.
Oh, you're astro.
yeah.
Oh, and here's
I was,
another-
well, I was X-ray, so X-ray astronomy.
Okay.
Um, I did a little bit of,
Hi. Hello.
but
so you talking, are you muted? I think everybody's muted.
Yeah, everyone's
Oh,
muted.
I'm unmuted. I'm sure that-
Oh, there, that's pretty on the right. Oh, that's my.
Oh,
10-year-old.
sorry, my microphone's unmuted.
There we go.
Hi, Daddy.
Hi, guys.
Oh, this is so laggy.
I did a little imaging stuff for Judy and her group, but not a whole lot.
Okay.
And I
Yeah.
see this
Well,
one.
I
but I
might
don't see
bounce
mom.
some ideas off.
yeah,
You
you should just move this whole thing to IRAF.
I can-
Wait,
Ah.
Wait,
What's that?
No.
Go ahead.
IRAF is the,
three.
what is it, like
It's,
world-based or,
Oh,
no,
oh, this sounds fun.
I can't even remember what it's based on. It's just, it was such an onerous installation process. I couldn't stand it. Like, oh, I need an iRef installed. Oh, hell no.
Okay. But I also read an article, if you just throw and splash paint on a wall
Yeah.
and do optical character recognition on it, 80% of it is valid Perl script.
Good. That's good. I like that.
Why I don't mess with it.
I love Perl. I don't use it for anything anymore, but occasionally some of the Perl regular expressions I
Yeah.
use it.
Is it Perl's the one that doesn't throw errors, right? Like whatever you give it, it's just like, okay, that's a new variable. Or something like that.
I can't even remember how it fails. So maybe it never failed.
what was there was one where like the first 5 columns,
Oh, that's Fortran.
yeah,
If something trails into the 73rd column, you get errors. Like, what's going on? Right, command, yeah.
Wait, I wanna try, wait, how do you throw away the calc? Okay. So I wanna try just words for the calculation, see what distance is.
Playing with this, so
yeah.
if
Isn't
you guys, if you wanna. Redirect. What is heat? What is that supposed to do?
It means throw.
Did you put a magic string in there? Well,
No, this is something kids talk about these
Yeah.
days.
Oh,
I don't understand it either. When I
They
was,
yeet you into space.
when I was finishing teaching, this, this would pop up and the kids would ask me to type something like, go do eat. Like, what does that mean?
oh,
Like,
okay.
sounds like something I would see a cartoon,
Yeah.
eating. Yeah. Okay.
I did 3, but it's still not working.
Kids, fancy words.
Wait, why won't it go back?
Yeah, click that.
Just go to the screen and once you click back in, it'll get it.
It's our junky house. It's on screen. Oh, now this is frozen. Is it frozen? Yeah, it's frozen. Dad, what's going on with this?
Well, yeah, I don't know. It's getting hotter and hotter.
Yeah.
It's when
Yeah, I'm just,
GPU, I guess, throttles back when it gets hot.
Yeah.
So it doesn't burn out.
Oh, yeah.
and then-
Yeah. Oh, this is, that's a USB-C model, but is it an Air?
It's, that's.
Oh, there's a
Rachel's-
Pro.
That's
Okay.
Rachel's former machine from work, from the university that I'm borrowing until she turns it in, so,
But you sell Linux on it.
yeah, yeah.
Does that have full GPU support and everything, or?
I don't know, this is all I've done on it.
Right, so I mean, it's possibly not even able to use GPU, and that's why everything is so laggy.
Oh,
because-
could be, yeah.
oh, Daddy, can you get into the virtual environment?
It's just type PyENV. So do people know PyENV? No, PyENV?
Yes, it's great.
And
I like
Rich turned me on to this, so you can, if you haven't used it before, you can have multiple Python versions installed and just
Yep.
flip between them. You want to go in 3.8 for something, and then you go in 3.11 for something else, you can just jump back and forth.
How do I?
Activate. And later, yeah. Yeah. So that right there, that it didn't, but it flipped to whatever Python version we had installed it on, and also the virtual environment for LADAR.
You got it laid out, yeah, there you
Wait, is it still light? 1, 2,
go.
Yep.
wow, 1.
Not as bad.
Yeah.
It used to be 3 seconds, so yeah. Oh my God, it's still showing up there.
Yeah.
Look at that computer. 1, 2, 3. 1, 2, 3, 4, 5. Wow.
Yeah, so I don't know what's
It didn't,
buffering it there.
it didn't
Yeah, it's
do,
something-
it didn't, it wasn't as slow on mine. I was watching it over on mine at the other end of the
Yeah, it's
counter
just
here.
really weird.
I guess it has to do with Zoom. I don't know
Yeah.
why it's buffering, but
Yeah.
but with Zoom running, it's lagging and
Yeah.
buffering. It doesn't do that. I think I showed the cube, right? When you pull off the images
Yeah,
off the
yeah.
cube. Yeah.
So, Jason in the chat has a question. Some,
Question.
oh, I can just read it. That's-
Yeah, you go for it.
Okay. Some camera lenses have polarized light filters. If you used more filters to subtract out everything but the laser. I don't know if I read that right. If you use more filters, subtract out everything but the laser, question mark.
Oh, have we tried that?
I guess.
Like, actual lens filters.
We haven't tried any. Finn, you want to answer the question?
Like
She's working on the code.
physical, I would imagine like, well, physical filter.
Daddy,
Physical
Yeah.
filter.
No, you just said some of these webcams have these filters.
Oh, in it.
Yeah.
Okay.
Usually it's like an IR filter, but
where's the code?
So that-
you know.
Look at my kid. My kid can get into Vim.
It's not there.
And get out.
Well, can you get out?
Can you get out?
Right.
Show us how you get out of Vim. So I'm so ashamed.
Fails the job interview.
I did it. No.
No. Get out of Vim.
I did it.
If you don't mind, see if you bring up the camera, just curious to see.
What am I doing?
If you can bring up the camera.
No.
Yeah, so Finnegan's busy. Who is it, Jason?
Yeah.
Yeah, we haven't put anything physical, any filters on or anything, but I don't know. If you've got more advice about dealing with webcams, it's welcome. I think we want to buy one with a manual focus, ideally, so it's not, because every time it refocuses,
Yeah.
that throws off your
Can you
calibration.
turn off the focus?
I don't know.
Oh,
I-
yes,
Wait.
it does see the red.
It's showing up. Daddy,
Ah,
look,
yeah.
it's
Infrared.
That's
Yeah.
cool.
Can you get it to track?
Oh.
You gotta stay in the
I don't know if I can
middle.
keep it up.
It's actually
Just
tracking
hold the
infrared.
button.
That's so cool.
Sorry, TV. It's getting your fingers.
It's too.
Yeah.
Can I
Oh,
try?
up a little higher. Yeah, a little higher.
Yeah, you have to go at the same level with the crosshairs.
Oh, yeah, because it's only looking at slice.
Oh, my God.
Yeah, it has a 50
Oh,
pixel.
okay.
It has a 50 pixel okay range.
I think it's ignoring you because it's
It's not
averaging over
steady.
It
time.
doesn't like you, it's running
Yeah.
away.
Oh, yeah, it's everything.
Yeah.
That's good, the average works well.
Down that way.
Yeah, it does, yeah, yeah. And none of the math in there is hard. I mean,
Yeah.
the heavy lifting sci-fi does. for you, so you just-
I think you were over the overlay.
Yeah,
There you go.
there you go.
That's-
1 second.
But that's what it, yeah, that's, as Josh said, that's what it's supposed to be doing. The little blips and stuff should not affect it. But the light flashing on and off should be
Yeah.
more of it.
Yeah, mitigated by the averaging.
Oh, yeah. I didn't.
It's better that your thing is better.
Okay,
than-
Dad, how do you open the code?
You can edit the code, okay. I don't think we can code live. Yeah,
No,
but-
but Daddy, I want-
That's part of the fun. That's
Well, you
okay.
can try it if people wanna
Yeah.
hang around. I mean, we're.
Yeah. Well, are we afraid of a little code? It's fun.
I have to drive Preeti to the airport. Is it okay if we? Preeti, oh, she's gonna.
1 second.
Oh,
Hi, Preeti,
No,
do you need us to drive?
I think
you
we're the only
to
people here.
somewhere?
Oh, okay, it's just us.
Wait, where'd everyone go? No, everyone left.
Yep.
Well, they
bored.
did stuff.
I suppose that's fair.
Oh,
We're
okay,
doing
so
it.
we're doing, okay, so it's in. LADAR. LADAR. And you can do them, LADAR is one of.
It's just like an app or something in there somewhere. Oh.
Well, that's probably one.
Ah, here we go.
Colon Q, then again, colon.
Ah.
So ashamed of you.
This is it. And favorite part of the code. Where'd it go?
And, oh, Z capital R, Z capital R, just press Z.
This is all the stuff in laser dots. Wait, this is the, wait, where's the best part? There we go.
kudos to you
So
for,
how much of the code have you written?
None. Dad did all the
Okay.
typing, but I gave him a lot of ideas.
I,
I told him to do the averaging.
She's a real project manager here. She's got the technologies and tells me what she wants. and-
How many story points was this?
Fish cut.
Yeah.
We're gonna set up Jira.
Oh, but every once in a while when I press Z, it works. I need to edit it. Did I add a Z?
U
Yes.
is undo.
I think space would also expand, or I don't know if that's just my config.
Yeah, my array.
But kudos to you for remembering, muscle memory literally as the characters to type.
It's hard. when
Yeah.
you're not typing it, yeah. So my kids, I made them, they've got, the schools all using like online Word and stuff like that
Yeah.
now, so they've been ruined, but.
I hate words.
She had to do her homework in LaTeX.
Oh, nice.
I have to do homework in Zen.
You made her?
Or no, sorry, not homework. If she was gonna write something, it had to be, like, so she's
LaTeX.
working on a book about animals. And we did it with a LaTeX template and.
Oh, and I'm writing a short story called Tree in there. But then something happens and I've never.
There's a plugin for writing authorship in Vim, or maybe you, where it,
Like publishing or?
well, it's for writing in that it just removes, it removes all the distractions, like those line
Oh.
numbers, centers everything in the middle, and makes it really pleasant to read and reduce
Like
distractions.
word processors.
Where's the
we
president?
feel, but,
Dad,
Just
where's
text.
the president?
Yeah,
Where's the president?
we didn't call it that.
No, that's not.
So. Well, I feel like people are gonna get bored if we sit here and type, so if you can.
But
look
where's
through
the
code,
president?
It's not there.
Well, rename it the president. Now.
And
Right
you're
there.
getting off on it, it was a great presentation. You're
Thank
getting
you.
off on a little tangent.
If it was a great presentation, then don't do anything on Zoom.
Are people, is there an after party this time, or are people doing that?
I don't think we've done that in a long
I
time.
know.
Oh, it's been a while.
Where's the president?
We'll talk about that later, okay?
So what do you mean by president? I gotta ask.
We were gonna call one of the classes president,
No.
like the main app or something. I don't know. you hear that? He said it's very impressive.
Yes, very impressive.
Thank you. He says thank you.
I said thank you.
Is that normal at 13?
It's my first 13-year-old, so I don't know. I think Finnegan's a perfect
I
case
think
of,
13.
just give them books and don't say no about it. Like, they just fill their heads.
Oh, he says no about a lot of stuff, so.
Well, I certainly credit to you for raising the
Thank you, thank
really
you.
well-rounded 13-year-old.
Yes.
Oh, okay,
I don't
I'm sorry,
care.
I just wanted to check it. So Finnegan is mildly autistic too, and she has got, we talked about this, she's got like the perfect amount of autism. So she's still social, right? Like normal social
Still
interaction,
introvert.
but she can get a stack of 20 books from the library and go through them in a day and know everything about mushrooms.
It was one day
That's
in
like
6
very-
hours.
6
And it makes her
hours.
very pedantic.
She doesn't seem too much of an introvert.
When I'm
No.
dancing, my dad says a pedant walks into a bar, and then I say, well, technically there's a restaurant with a bar on the side. It's a like a joke we do.
Yeah.
What's your?
Oh, this is the slicey
What?
thing,
Interest in
I think. Wait, what's this?
Well, I studied the training last year. Gone by then.
Oh,
Change career.
oh, okay. On your own or?
Yeah.
Oh,
Yeah,
okay.
well, I'm doing a program of band online. It's on open classrooms.
Oh,
It's French. And but yeah, so yeah, almost at the end of my training.
that's nice. So you're gonna try to switch career from?
Yeah.
From what?
From what? That's a good question. I was working in e-learning. I was construction engineer and having a project manager. Creating a platform and tool to make it done.
Oh, e-learning.
Yeah, e-learning.
Oh, okay, yeah.
Learning management system.
Ranging on his neck.
Wants to be targeted.
Good marketers. I think if you want recommendations for resources, I think probably somebody here is.
I want an infinite loop again.
Is
There you
it
go.
faster now? Now it's faster, right?
Wait,
And I was doing much better.
it's better, still bad.
No.
Look at my hair. Did you see that? That is a.
Yeah.
Where's the infinite loop thing?
It's right there. You got it. It's just not very zoomed in.
Hmm?
As you can
Do
see
your
you
Zoom function. There you go.
Not the other one.
or the
Oh,
other
you're
one.
pointing at the wrongs. Yeah.
Yeah,
You gotta be this one, right?
Hey,
What you doing? You gotta be on this one.
There you go. Oh, too far.
we do infinite loops a
I'm
lot.
shitting
Fun.
it. Why is it?
I think we flipped it on purpose in the beginning for some reason, and we should probably flip it back.
Wait, flip what?
We
Wait,
flipped we flipped the image, which is the NumPy operation.
Oh, yeah, that's infinite there.
Ah, yeah, there you go.
It's Eddie said it's so laggy, you can see it update in each of the screens. Look, so there, and then
Yes.
next screen, and then next screen.
Oh, it is faster. Yeah, so here it's fairly smooth. Over there, it's really laggy. So that's a Zoom thing, it's right.
Yeah.